Okay, so I was saying, welcome to today's lesson where we'll be looking at chapter 8, and we'll be looking at a topic that is slightly similar to what we covered in the previous chapter, that is stored procedures. In chapter 8, we are going to look at triggers and how to implement transactions in SQL Server. So let's quickly go to my presentation. Today's lesson will be mainly theoretical. There are a number of basic or introductory concepts that I need to introduce. Then in the next lesson, we're going to look at how those concepts are actually implemented in SQL Server. And unless you are in an environment where there's a lot of noise, I don't mind you keeping your microphone unmuted, and you can ask questions or stop me if you think that I'm going too fast. And I'll be posing some questions, hoping that I can get some feedback from you.
Okay,
so,
sir.
I said, in chapter 8, we'll be working with triggers and transactions. In this chapter, we are going to look at implementing triggers, under which we are going to look at identifying the types of triggers. Then we'll look at creating triggers. Then we'll look at managing triggers. In our context, whenever I talk about managing, just keep in mind, I'm talking about things such as modifying objects, deleting objects. Okay.
Okay.
The second part of this chapter looks at implementing transactions. And under transactions, we'll look at creating transactions, reverting transactions, implementing transactional integrity, and the last part will be resolving deadlocks.
Yeah.
The objectives of this chapter are basically two. By the end of this chapter, you should be able to implement triggers. You should be able to create, modify, or delete triggers in SQL Server. Secondly, you should be able to implement transactions. So you should be able to explain what transactions are. You should be able to create them. You should be able to vet the transactions. You should be able to look at the different types of transactions that can be implemented in SQL Server. Implementing triggers. Sometimes when you are manipulating database objects, you might need to also perform manipulations on other objects. Certain activities that you perform in SQL Server will require that you do not only make changes to one object, it might require that you make changes to other objects in the database. Now, to do this, in SQL Server, you can use triggers. The name is used in such a way that it should give you an idea of what triggers are all about. Triggers consist of a set of T-SQL statements which are activated in response to certain actions or events, such as inserting or deleting data in a table. So a trigger is not going to be used by you per se, but it's going to sit and wait in the background, and it's going to be executed as a response to certain identified events that have occurred. Triggers are used to ensure data integrity before or after performing data manipulation. We did look at data integrity. Basically, in a nutshell, when we talk about data integrity, we're saying the data stored in a database should be complete, should be reasonable, and should make sense. So one way you can implement data integrity is to use triggers. We did look at another way in which you can ensure data integrity. Can anyone remember what approach you can use to ensure data integrity?
Data integrity. I think it is a system whereby the child table, like you cannot insert data in the child table that is not in the parents table.
Oh, okay. I'm not asking you to define data integrity. I'm just saying, what other ways can you ensure that the integrity of the data in the table? We did look at one particular approach. We looked at constraints. We said that constraints can be used to ensure data integrity. Now, what are triggers? Triggers are a special type of stored procedures that are executed in response to specific events. In other words, they differ from the general stored procedures in the sense that triggers are a unique type of stored procedures. These procedures are only going to run as a result of something happening. We said stored procedures can be executed by the person, the user of the database system running the SAMS application, or someone interacting direct with a management studio. But for triggers, these are going to automatically run when certain events which you have defined have occurred. Now, there are different types of triggers, and SQL Server provide you with quite a wide range of different triggers which can be used to meet different needs of different organizations and individuals. Now, because there are so many of these triggers, there are multiple ways in which you can group these triggers. Triggers can be nested and executed or fired recursively. I'll be explaining more on what recursive mean in our context, but generally in programming context, when you talk about something being recursive, it means that it's executed repeatedly. The same thing is carried out more than once. Okay. SQL Server supports basically two types of triggers. The first one is DML triggers. The second is DDL triggers. And I'm sure those acronyms should be familiar to all of us. DDM is the abbreviation for data manipulation language. It's a component of SQL standards that is the commands that you use to manipulate information stored in the database. Okay, so a DML trigger is fired when data in the underlying table is affected by the data manipulation language statements, such as insert statements, update statements, or delete statements.
Okay.
Is drop a statement a data manipulation language statement or not?
Drop is a data definition language.
Okay, so drop is a data definition language statement because it is used to change the structure of the database. Data manipulation is concerned with only the data which is stored in the database. It doesn't affect the data structure. It doesn't change the columns which are in the tables, in the lining tables. It doesn't create new tables or other database objects. It will only be used to enter new data into existing tables. It will be used to modify data which is existing in the table or to delete data which is already in the table.
Okay.
DML triggers help maintain consistency and reliability and correctness of data in the database. Again, I'll be showing you in more details as we go on. So triggers are going to be implemented, or you as a database developer or application developer, you need to make use of data manipulation language triggers as a means to help maintain consistent, reliable, and correct data in your database.
Yeah.
These triggers enable the process of reflecting the changes made to one table to reflect in other related tables and objects. There are times when you make some changes to the data contained in one table, but you need to also update or make changes to data which is related to what you are changing in other tables and objects. So
Okay.
triggers are used for making sure that the changes made to data in one table are also reflected in related tables.
Okay.
The data manipulation language triggers have the following characteristics. Please, these are important. You need to understand them, not only because your ability to use them effectively depends on them, but also you can expect questions in exams or tests about these characteristics. The first one is that data manipulation language triggers are fired automatically by SQL Server whenever a data modification statement is executed. A data modification statement is, like I said, insert statement, update statement, delete statement. So you can create triggers which can be activated or evoked by some of these activities.
Okay.
The second, data manipulation triggers cannot be explicitly evoked or executed like the ordinary stored procedures. Remember, when dealing with stored procedures, we are using the command execute followed by the name of the procedure. You don't do that for triggers. In other words, you, the person dealing with the database, are not going to directly interact with triggers. Triggers are going to be executed automatically by the database management system.
Okay.
DML triggers prevent incorrect, unauthorized, and inconsistent changes in data. So they are supposed to be unauthorized, okay? And inconsistent changes in data. For example, I think, is it Gift2 mentioned, there are times when you have a foreign key. Sometimes the foreign key may allow changes to be made to the secondary table without affecting the primary table. So you can use data manipulation language triggers to prevent such kind of actions being taken. DML triggers do not return data to the user or to the application. Remember, when we looked at stored procedures, we said that stored procedures can accept input parameters and in some cases can produce output using output parameters. For triggers, you do not have to produce any output. They do not return any output or result to the user or to the application. They execute, they run in the background and perform certain actions only. And this is, the next one is a limitation of the SQL Server. DML triggers can be nested up to 32 levels. Do we understand what this means?
No, sir.
No.
Okay. Again, I'll go into the details a bit later. But when we talk about nesting, we simply mean something is placed inside another. So, if, for example, you have an if-else statement, you can have a nested if-else statement. What that will mean is that you have the if-else statement. Now, inside it, there is another if-else statement. So when you have such a case, it is said to be nested, to be placed inside another statement. So we are saying triggers, you can have a trigger which will have in it, it's going to have other triggers. And those other triggers can also have other triggers inside them. And those other triggers can also have other triggers in them, up to 32 levels.
Okay.
Is that okay?
Yes, sir.
Okay. So the nesting of triggers occurs when trigger performs an action that initiates another trigger. Again, sorry, that's my typing error. Okay, that's supposed to be initiates another trigger. So this trigger will be initiated maybe by updating data in a certain table. Once that trigger begins executing, it's going to also start another trigger, or it's going to make changes to another table which has a trigger associated to it. So that's what we mean by nested triggers. So we have one trigger which executes, and in the process, it initiates another trigger, or it executes another trigger. The last characteristic is that triggers make use of what are called magic tables. There are two magic tables in SQL Server, which are called inserted table and deleted table. And let me just explain a bit on that. Let me just switch to, okay. Depending on the operation of that you're performing, DML triggers can be further categorized. So here I'm saying we have classified triggers according to the type of data language used, okay? In which case we have data manipulation language triggers and data definition language triggers. But you can also classify triggers in another way, based on the actions that those triggers are going to perform, or the actions that are going to initiate or start the trigger. So if you classify them in this way, these triggers can be, and this is the subgroup of data manipulation language triggers. We can have insert triggers, delete triggers, update triggers.
Okay.
Insert triggers are fired or executed whenever an attempt is made to insert a row of data into the table to which the trigger is associated.
Okay.
When the new row has been added, then the trigger is going to be executed. This is where I wanted to explain what I meant by the magical tables. When you have a table, and then probably that says product, and let me just say ID. Then there we have maybe the description, and maybe there we have the price. And so here we can have 1, 2, 3, and so on. Now, I'm looking at the first type of trigger, which is the insert trigger. This one, insert trigger. Now, what happens is that when you insert data into a table, you are adding a new row to this table. So there will be row number 4 added. Okay. If you are deleting or if you are updating, for example, we do have these, the first column has values, and we want to set the price of the product with ID number 2 to maybe 9.
Yeah.
9.5. Oh, let me just use the text. My handwriting is terrible. Set 9.50. We want to, it doesn't have this. What is going to happen is that first, before we update this row, before we update, is going to have information such as it's going to have 2, then the other 2 columns are going to be empty. After we update information, this new row is going to be, it's going to have 2. We are not doing anything on the description. We are going to have 9.50. So have 2, and let me just delete this. So we have 2 there, and then we're going to have 9.50. And that is going to be the new row. So what happens is that SQL Server is going to save this row in a special table before you make changes to it. And that's the deleted table. It's a system table, so it's not visible. And it's only used during the time that you're using the database. Also, the new row which has been inserted is going to be, so this is going to be, it will appear in the table as like it is now, but it's also going to make a copy, and it's going to be inserted, placed in a special table called inserted. Then this one, okay. So it's going to be placed in a new table called inserted table. The data which was there previously is going to be moved to a new table, which is a system table called deleted table. So these are the 2 tables. You won't see them appearing when you go to Objects Explorer. You won't see these tables, but I'll show you how you can access them and check the contents. So before changes are made to a table, SQL Server is going to take precautions so that in the event that you need to reverse those changes, there will be no problem. And it uses 2 system tables. One is called deleted table, which is used to store rows which have been deleted, and inserted table, which is used to store rows which have just been added to table.
Okay.
Are we together? Okay, so let me go back to the PowerPoint presentation. Okay, so newly inserted rows are added to the inserted table. That's a system table. Now, the other type of trigger is the delete trigger. When executed, this is executed whenever an attempt is made to delete rows from a given table. Again, please just delete those repeated words for me. So when you attempt to delete rows from a table, the data which is being deleted, those rows are going to be placed in a special table called deleted table, a system table.
Okay.
And if you have defined a trigger, it's going to be activated. The deleted and trigger tables do not have any rows in common, as it is the case for the inserted and the triggered tables. What I mean is this. When you are inserting data into a table, we said SQL Server will take what is existing there and place it in the deleted table like that. Then it's going to take the new information and place it in the inserted table. So what is here is going to be identical to what is there. But when you are deleting, this is just going to be removed and placed in this table. There won't be a similar row here and there. Are we together?
Yes, sir.
Okay, so that's what I mean. Update triggers are fired when an update statement is executed in the trigger table. The trigger table is a table to which a trigger has been assigned. Update triggers uses the two logical tables for its operations.
Okay.
The deleted table contains the original rows and the inserted table contains the new row. That's what I was explaining in here.
Okay.
So the deleted table is going to contain the data which was in the table before updating. The inserted table is going to contain the new data or new rows, which is now in the new table.
Okay.
The three ways of implementing referential integrity by there are three ways of implementing referential integrity by using the delete trigger. The first one is called cascade method. The second is restrict method. And the third is nullify method. And I'll start with this in the next session. We'll take a short break, then we'll resume our lesson.
Okay, sir.
Okay.